Welcome to Easy Elim, Learning Simplified. My name is Ruth, and today we are going to be looking at the topic Structure of the Atom and the Periodic Table, which is a Form 2 topic. And our subtopic for today is Valency. So in the previous lesson, we looked at charges and oxidation numbers. But for the lesson today, we are going to see what valency is and the difference between valency and valence. And we are going to look at a few examples and finally conclude with some questions. So we'll start with the valence electrons. Valence electrons refer to the electrons in the outermost energy level. So if you write your electronic configuration like we did in the previous videos, the outermost energy level gives you the valence electron. So like in calcium, which has configuration of 2.8.8.2, it has 2 electrons in the outermost shell. So it tells us that the valence is 2. Oxygen with the electron arrangement of 2.6 has 6 valence electrons because they're the number of electrons in the outermost shell. Phosphorus with the electron arrangement of 2.8.5 has 5 electrons in the outermost shell, so it has 5 valence electrons. So let's see what valency is. Valency refers to the number of electrons lost or gained during a chemical reaction. This looks like similarly when we were defining on charge and oxidation number. But now for valency, it's also referred to as the combining power. It does not have the positive or negative, as in the case of charge and oxidation number. And you can see the difference between valence electrons and valency. Valence electrons, they are on the outermost energy level. Valency now is the number of lost or gained. This is the number of electrons lost or gained. So let's look at some examples. So calcium with the electronic configuration of 2.8.8.2 has 2 electrons in the outermost shell. So we'd say it has 2 valence electrons. But if we look at either it gains or loses, we say it loses 2 electrons. So the valency would be 2. Oxygen with configuration of 2.6 gains 2 electrons. It has 6 electrons in the outermost shell. So the valence is 6, but the valency is 2 because it is gaining 2 electrons. Phosphorus with an arrangement of 2.8.5 has 5 valence electrons, so it gains 3 electrons to be stable. So the valency is 3. Aluminium with configuration of 2.8.3. It has 3 valence electrons, but it loses 3 electrons, so the valency is 2. So you hear the difference between valence and valency. So some elements, especially the transitional metals, usually have variable valencies. For example, iron can have a valency of 2 or 3. It can gain it can lose 2 electrons or 3 electrons. Copper can have a valency of 1 or 2. Lead can have a valency of 2 or 4. You can go back to the oxidation numbers. You can get the valency from there without the positive and negative. And when we look generally at both the atoms in the periodic table, so metals that have a valency of 1 is sodium and potassium. The ones that have a valency of 2 is calcium, barium, magnesium, zinc, iron, lead, and copper. And the ones that have a valency 3 is aluminium and iron. Iron is occurring in 2 places because it can have variable valencies. For the non-metals, the one that have a valency of 1 is nitrogen, chlorine, fluorine, and hydrogen. The ones that have a valency of 2 is nitrogen, oxygen, and sulfur. And the ones that have a valency of 3 are nitrogen and phosphorus. So we also have compounds known as radicals. They're also referred to as polyatomic ions. These are usually ions or a group of ions made up of different atoms, and they have a net charge. So they have an overall charge that is used for also in chemical reactions. So they can be referred to as radicals or polyatomic ions. And also radicals have valences. We're going to use these balances when we are forming compounds. These balances are equivalent to the charge. So, for example, if you look at ammonium ion, it has a positive charge, so the valency is 1. Hydroxide ions, which have a charge of negative 1, so the valency is 1 as well. Nitrate with negative 1, so valency is 1. Hydrogen carbonate, negative 1, valency is 1. Hydrogen sulfate, negative 1, so the valency is 1. We have the carbonate with a 2 minus, so the valency is 2. Sulfate with a 2 minus, the valency is 2. Sulfide with a valency of 2 minus, the valency is 2. And then the one that has a valency of 3 is phosphate. It is important for you to note that these charges are also equivalent to the valency. We are going to use this when we are forming compounds. So let's look at a few questions. How many valence electrons are in the following elements? Fluorine is atomic number 9, so it's 2.7. So we have 7 valence electrons. Lithium is atomic number 2, so atomic number 3. So it has 2.1, which means it has 1 valence electron. Phosphorus is atomic number 15, so it has 2.8.5, so it has 5 valence electron. Zinc, we get the valence electron of zinc depending on the oxidation number. So the valence of zinc is going to be 2. The valence of calcium is 2.8.8.2, so the valence is going to be 2. For carbon, it's going to be 2.4, so the valence is 4. Iron is going to be either 2 or 3, and iodine is going to be 7 because it has 7 electrons in the outermost shell because it is in group 7. And then you fill the table with the correct values. We have fluorine and the fluoride symbol. So the protons are going to be 9. Number of electrons, because it is an ion, it's going to be to gain 1 electron, so it's going to be 10. And the charge is negative 1, and it forms an ion called an ion. Then we go to this, you skip this because it's beyond the 20 elements. Then number of protons 16. This tells us that it is atomic number 16. This is sulfur. And the sulfide ion is S, 2 minus because it loses 2 electrons. So the number of electrons after gaining, is going to be 18. And it forms an ion called an ion as well. Potassium will form K with a positive, it loses 1 electron. It has 19 protons, and the electrons will be 18 because it has lost 1 electron and it forms a cation. Lastly, we have calcium, which becomes Ca with a 2 plus. It reacts by losing 2 electrons. The number of protons are 20. The number of electrons when it loses 2 electrons becomes 18. The charge is positive 2 and it forms a cation. So that brings us to the end of valency and valence. I hope you have been able to understand. So looking at one more last example, the valency of hydrogen is going to be 1 from the charge. Sodium is going to be 1 because it's 1. Potassium is going to be 1. Silver is going to be 1. Ammonium ion is going to be 1. Magnesium is going to be 2. Calcium is going to be 2. Zinc is going to be 2. Iron is going to be 2. And gold is going to be 2. So that's it. So in the next lesson, we will be starting on formation of simple compounds. See you in the next lesson.